Let's hunt malware with volatility. 6 questions, 1 memory dump, and not much time. This is Honeynet Collapse, a blue team forensics focused CTF. Join me as we're solving the second challenge, lost in RAMSlation. A DMZ system has been acting strangely slow. Internal teams couldn't find the cause, so we've been called in. Our job? Dig through and uncover the truth. From the challenge description, we see this is a memory forensics case. A memory dump from this DMZ system is available in home Ubuntu. Volatility is already installed on the analyst machine. If you haven't used it before, it's an amazing tool for memory forensics. You give it a raw memory dump, tell it which plugins to run, and it pulls out all kinds of useful information. So instead of staring at a massive binary blob, you get structured, human-readable reports you can actually work with. We're also given some tips. Threat actors tend to mimic systems applications, so we're likely looking for something disguised as a legitimate Windows process. And the second tip, some volatility output has already been pre-generated in home Ubuntu out. Normally, we'd run those plugins ourselves, but the CTF organizers handled all the heavy lifting, and we get to jump straight into the investigation. Since the memory dump is on a Linux system, let's drop the split screen. And let's SSH in. And now the password. Let's see what we're working with. There's the memory dump. And it's over 2 gig in size. Way too large to pull locally. They mentioned volatility output is available in home Ubuntu out. Let's see what kind of reports have already been pre-generated. That's quite a lot of reports. I see mcache, cmd line, netstat, netscan, pslist, pscan, malfind. That's pretty nice. Pretty sure everything we need is right here. For the first question, we need to find the absolute path to the malicious file. So I'm thinking the malware is running from either user, stamp, app data, or something like that. Let's grab for any processes that reference those folders. That doesn't look too promising. None of these seem off. Let's see all the file. SVG host, Amazon agent. Okay, this process 2928 looks shady. Microsoft Update DLL in Windows tasks. This feels like it's disguised to look like the legit thing, but this DLL shouldn't be in tasks. Yeah, I don't think anything else immediately suspicious. Let's try this DLL. Alright, that was the right answer. Next question. What process ID was assigned to execute the initial payload? That's a pretty straightforward answer. We already saw it was 2928. Yeah, we're on a roll here. Next question. What was the full command line used by the attacker to launch the initial execution? And again, we already have the answer. It was the rundll32 command we saw earlier, used to launch the fake Microsoft Update DLL. Next question. The attack launched various processes. What is the name of the final process in the chain? Okay, for this we're gonna take a look at PS3 that was kindly generated by Volatility. and we are going to grep for 2928, which is the initial process ID. That will show us shell processes spawned by the initial payload. Is it SVC host? Let's try that. Nope. Alright, how about Notepad? Yep, that was the correct answer. Next question. What are the first 5 bytes in hex of the Meterpreter shellcode injected into it? Okay, so we know the process we need is Notepad, and Meterpreter is malware, right? So let's take a look in malfind. That's another report file generated by Volatility, and this one contains suspected malware dumps. And here it is. First entry tagged by Volatility as malware is Notepad, which we already knew. Let's grab the first 5 bytes for our answer. Oh whoops, let's get rid of the spaces. Still no. Alright, let's keep looking. There's another entry for Notepad and it has the page execute attribute. Let's grab the first 5 bytes of this second entry. Getting rid of the spaces. And boom, that was correct. Final question. The IP address for lateral movement using port 3389. For this, let's grep for the port 3389 in NetScan, Volatility's report with the active network connections. Looks like we have 2 entries, and since the question was kind of vague, we can have the port 3389 either at source or destination. Trying the first one, let's grab that IP address. Nope, not that one. Let's grab the second IP address. And that was the correct answer. We completed the second challenge. Taking a look at the leaderboard. Oh damn! I'm in the 3rd position now. So a bit of a flex moment right here. If you enjoyed this, please hit that like button. It really helps me out. And if you'd like to get notified whenever I post new videos like this one, make sure to hit that subscribe button. In any case, I will see you on the next one. Bye bye.